Alright guys, welcome to Ionic solids. So we're building up again to the mole concept, but I need to put all this stuff together for you. Alright, so in ionic solids, we have something like sodium chloride. And if you remember, an ionic solid does not have a net charge. So for instance, sodium chloride, there is no charge on this. And the reason that is because the individual ions, the sodium and the chloride, have a balanced charge. So you have a +1 here and a -1. Well, 1 minus 1 is 0. So there's no net charge on an ionic solid. Take a look at barium sulfide. In barium sulfide, or BAS, again, we have balanced charges. And so you would think there's ones here, and it's actually a 1-to-1 ratio. But it's actually, if you look on the periodic table, you'll see that barium's in group 2, which is a 2+, and sulfur is in group 6, right? Group 6, so it has a 2 negative charge. Check me on that one. So we would have a 2+ and a 2- here. And what I want you to see is that the 2+ and the 2- balance each other out. So to get the charges, remember we go to the groups on the periodic table. And they should balance themselves out in a ionic solid. Now it's not always that easy. For instance, take a look at calcium chloride. We have here, for every 1 atom of calcium, there's 2 molecules of chloride. So what does that look like? When we look at the charges, we have a calcium 2+, that's the charge on calcium cation, and chloride has a -1 charge. Well, the reason this 2 here, you need 2 of these chlorides to balance. Let me show you what I mean. 2 plus 2 times -1. Well, that's +2 minus 2 is 0. That's why these subscripts are here. They have to balance each other out. Remember that ionic solids form these nice crystal structures. There's no cations or anions hanging off of the side. Now let's take a look at aluminum oxide. Aluminum oxide is Al2O3. And so we have, if you look up on the periodic table, aluminum is a +3 charge, oxygen is a -2 charge. Now, how many do we have? We've got 2 aluminums to balance, and we've got 3 oxygens. These subscripts tell us how many of each of these ions we have. Let me close this door real quick. I'll give you a break to take your notes. All right, now we can also have molecules bound to an ion. So in calcium hydroxide, we have calcium, which is 2+, bound to 2 hydroxides. So hydroxide has a -1 charge. Well, the charge is balanced. +2 and 2 - 2 is 0. All right, so these subscripts again tell you how many of the molecules or the atoms that you're going to have. What you need to know here, the main idea, is that these subscripts will tell you how many of the molecules you have. So for here we have 2 times 3 is +6, 3 times 2 is -6, 6 minus 6 is 0. Ionic solids have a net charge of 0. The other thing I wanted to make sure you understood were these parentheses. So if I were to ask you how many atoms are in this molecule of calcium hydroxide, you would see that there's 1 calcium and that there are 2 molecules of hydroxide. So that means that there are going to be 2 oxygen and 2 hydrogen. So make sure you understand that these parentheses here work like a distributive property, where we're saying that there are 2 of those hydroxide ions. All right, let's do some practice. Again, I just want you to you to figure out how many atoms are in each of these molecules. These are actually, not molecules, they are ionic solids. And I know that because I have a cation and an anion bound together. Pause the video and list out, and let's see if we can figure out how many atoms are in each. All right. Welcome back. Let's try it. So in here, how many atoms do I have? Well, I have sodium, I have 2 atoms, I have 1 sulfur, and I have 4 oxygen atoms. So that gives me a total of 4 plus 2 plus, that's 7 atoms. All right, let's try aluminum sulfate. So here I have 2 aluminum atoms, and now I've got 3 sulfur, and I have 4 times 3, which is 12 oxygen. So basically what this means here is I have 3 SO4s. So if I add that up, I've got 3 sulfurs, and 4 plus 4 plus 4 is 12 oxygens. So that one's kind of tricky because, again, you have those distributive property with the molecules there. All right, let's try calcium nitrate. So we have 1 atom of calcium, and now we've got 2 atoms of nitrogen and 6 atoms of oxygen. Again, this is like saying I have 2 nitrates. If I add them up, I've got 2 N's and I've got 6 O's. So the key here is remembering to distribute when you see the parentheses to find the number of atoms. Now I just want to review very quickly one last time the difference between a formula unit of an ionic solid and a molecule. The formula unit, for instance, sodium chloride, is a crystal lattice structure. It's very strong, and we've studied that. But the reason why it's sodium chloride is because we just look at one ratio. That brown is the sodium, that purple is the chloride. We only look at that. Otherwise, we would say like sodium, 1 billion, chloride, 1 billion, ... And that's too complicated. There is actually 6.0 times 10 to the 23 molecules in 1 mole of sodium chloride. So the reason that we say sodium chloride is we look at just one of those of the ratio. So it's for every 1 sodium, there's 1 chloride. In a molecule, we end up with chains of things bound together. So the difference between a formula unit and a molecule, the formula unit is a crystal lattice structure. The molecule is a different structure, and it's often bound differently. There's some things free moving around. So molecules tend to have more intermolecular forces around them, whereas this formula unit is very strong, very tight intramolecular forces. All right, that's enough for now. One more thing I should tell you before I go. Formula unit, ionic bonds. They're very strong. Whereas in a molecule, you have your covalent bonds, which tend to be a little bit weaker. All right? And we saw that when we looked at the lab that we did on melting point of sugar and salt. All right, I'm going to stop talking. You guys are good now.